This video is on interval notation and set notation, two notations that are used quite frequently throughout mathematics that you should be aware of. To begin with, though, we're going to start with something that we're used to seeing. We usually do some work and we get this down to say something that looks like x is less than 3. We all know that means the solution would be all numbers that would be less than 3, to the left of 3 on a number line. So on a graph, if we looked at the number line, say here's the number line, we would say, all right, there's 3. And I'd say, all right, all numbers to the left of 3, and we would shade out this way. You ever remember doing that? Put a little arrow on the end saying it's shading out that way. And then at the number 3, you might be used to putting like an open circle or a closed circle. We don't really use those too much anymore. So it was an open circle if the number was not included, and it was a closed circle if the number was included. Well, in this case, or not this case, from now on, we're going to write this as a parenthesis if the number is not included. So use a parenthesis if the number is not included, and we use a bracket if the number is included. We'll see one of those in just a minute. Well, so say we have x is greater than or equal to 3. All right, so here is where the 3 is included. So we'd say, all right, there's 3, and this time we want to shade out to the right because we want all numbers larger than 3. And we're shading because there's an infinite number of numbers that are larger than 3 there, right? But then at 3, 3 is included, we put a bracket to say, all right, 3 is included. Parenthesis for 3 not being included, bracket for the number to be included. So the interval notation is pretty nice. If we understand the graph idea, we're just going to write that interval over here. We say, all right, so what's the smallest number in this particular interval over here we're shaded? Well, this continues to go out towards negative infinity. So the smallest number, for lack of a better phrase there, is negative infinity. And then we put a comma. I say, all right, what's the largest number in our interval? Well, the largest number is 3. Even though we don't get to 3, we get really close to 3. So we're just going to put 3. We can't actually put the number that's immediately to the left of 3 because we can't get infinitely close to that number 3. And now we say, all right, is 3 included or not included? Well, 3 is not included. And so just like we did on the graph, we're going to use a parenthesis. Infinity, whether it's positive or negative, is never included. So we'll use a parenthesis always on infinity. And this is the interval notation. It says all numbers that are less than 3. Just another way to write it. Okay, so down here on the greater than 3, it's a similar thing. What's the smallest number for our interval? What's 3? And then a comma. What's the largest number in our interval? Well, this time we shoot off to positive infinity. I say, all right, is 3 included? Yes, 3 is included, so we'll put a bracket. And infinity is never included, so it gets a parenthesis. Let's do one more before we talk about set notation. Let's do negative 2 is less than or equal to x is less than 5. So this says we want all numbers that are greater than or equal to negative 2, but at the same time, those numbers have to be what? They have to be less than 5. So really, on a number line, we're talking all numbers that are between negative 2 and 5. All right, because numbers that are greater than negative 2, but at the same time less than 5, they all fit right inside here. And then we say, all right, what happens at negative 2? Is negative 2 included? Yep, so negative 2 is included, so a bracket. 5 is not included, so a parenthesis. So then the interval notation for this would be bracket, negative 2, comma, 5, parenthesis. All three of these notations say the same thing, just in a different form. And interval notation is used quite frequently because it's a nice, easy one to write out. Now, set notation is very similar to the algebraic notation that we have over here on the left. We use braces to denote sets. So a brace looks like, and it'll take some practice to drawing those correctly. And then it's whatever letter you're playing with. Well, in this case, we're playing with x. So put in an x. And then we put this vertical line. Now that vertical line means such that. So right now we're reading this as all x's such that we want something to happen. Well, what do we want our x's to be? Well, we want all of our x's to be less than 3. So the braces say this is a set. It denotes a set. And we read this as all x's such that x is less than 3. So any number that is less than 3 fits into our set. So down here on the second one, we have a brace. And we want all x's such that x is greater than or equal to 3. So any number greater than or equal to 3 fits into our set. And this last one down here, it's all x's such that -2 is less than or equal to x. Whoops. X is less than 5. So, algebraic notation looks like this. And typically when you're solving an inequality, you're going to end up with one of these in the end. The graphical representation looks like this for each one of these situations. We shade all the solutions, and since we're dealing with inequalities, there are going to be an infinite number of solutions usually. That's why we shade. Then interval notation is the new notation that we're going to see quite frequently. We need to understand that this means all numbers between -2 and 5, -2 being included, 5 not being included, so forth. And then this is set notation that we'll see from time to time. We're going to use interval notation the most. And that's it. If you have any questions, please email me or let me know.